All right, guys, your essential question is how do we evaluate a definite integral using the fundamental theorem of calculus? This is one of the most crucial theorems in math, the fundamental theorem of calculus, and find the average value of a function over a closed interval. Now, for this video, we're only going to be looking at the fundamental theorem of calculus. In another video, I'll be doing average value. So let's go ahead and just jump right into it, and I'll go ahead and give you the theorem. The first fundamental theorem of calculus is basically this right here. And what it means, obviously I could read it to you. It says the definite integral, because I know it's a definite integral because it has a lower limit a, upper limit b. So the definite integral ab of f of x dx is equivalent to the antiderivative of f at b minus the antiderivative of f at a, evaluated at a. So basically what this fundamental theorem of calculus means is, if you remember, the definite integral basically stands for the area under the curve on the interval a to b. And so what this is saying is that one way you can find the area under the curve, or aka the definite integral, is to first find the antiderivative and then evaluate your upper and lower limits in that antiderivative, which is very crucial, and that's why it's so fundamental, is the fact that it relates definite integration to antiderivatives, and that's crucial. That's one of the most important theorems in math. All right, there are also some alternate forms. However, we're mainly going to be looking at this form. All right, so let's go ahead and jump right into an example of how we could use the fundamental theorem of calculus. For example, it wants to evaluate this definite integral from -1 to 2, and the function, this might be a little bit hard to see, but it's x cubed plus 2 dx. Well, the first thing that you're going to want to do using the fundamental theorem of calculus is find the antiderivative. Well, I noticed that this is x cubed plus 2, so I'm going to split this derivative apart. So I'm going to have -1 to 2 of x cubed dx plus the integral from -1 to 2 of 2 dx. And so now I'm going to find the antiderivative for each one of these parts. I'm going to use the power rule on x cubed. So I'm going to add 1, and so that's going to give me x to the 4th. I'm going to do the reciprocal, and so that'll be 1/4. And then the antiderivative of 2 dx would simply be 2x. Now, guys, we're not going to put plus c, because you only put plus c if it's an indefinite integral. This is a definite integral. Okay, so we found our antiderivative, and now the fundamental theorem of calculus says that we're going to evaluate our antiderivative at the lower limit, which in this case is -1, and the upper limit, which is 2. All right, now here's what's crucial, guys, is that you want to evaluate the upper limit first. Okay, so what I'm going to have is I'm going to have 1/4 times 2 to the 4th plus 2 times 2. So I've plugged in the upper limit into my antiderivative. Now, here's what's important. If you remember the formula from the fundamental theorem of calculus, the formula says f of b minus f of a. In other words, f of the upper limit minus f of the lower limit. Whenever it says that minus, that inherently means change your signs. So when I evaluate the lower limit, what I'm going to do is I'm going to change the signs of my antiderivative as I go. So this positive 1/4 is now going to be -1/4, and I'm just going to evaluate -1 to the 4th. And this positive 2x is now going to be minus 2x, and I'm just going to evaluate that -1 in for that value. All right, now we can do some arithmetic. 2 to the 4th is 16. 16 divided by 4 is 4. 2 times 2 is 4. and then negative 1 to the fourth is positive 1 times negative 1/4 is negative 1/4, and then negative 2 times negative 1 is a positive 2. Combine my like terms, 4 plus 4 is 8, plus 2 is 10. 10 minus a fourth is 9 3/4, which is equivalent to 9.75. Now written as an improper fraction, 36, and you get 39/4. But any of those would be equivalent answers, and so that would be the definite integral answer. And then geometrically what this means is that for this function, x cubed plus 2, from negative 1 to 2, the area under that curve is 39/4.